Hello, everybody. Mr. Chan here. I'm about to do Algebra 1, Lesson 1-4 on literal equations and formulas. Please turn your note takers to page 13. Here we go. All right. We have a little opener. Please read along with me as I read out loud. Nora drew a non-square rectangle. Then she drew the length of each side from end to end to make a line segment to represent the perimeter. Little vocabulary before we get started with the actual problem. Formula is an equation with two or more quantities. In algebra, we call them variables. A literal equation has multiple variables in them. Here's an example of that. D equals RT. You might recognize that from your science classes. That is the distance equals rate times time. You can actually rearrange those variables around and get two other variations for this. D divided by T equals R, and also D divided by R equals T. You might hear me say this a few times throughout the year. Rearrange the furniture. Furniture meaning variables and values across the equation sign. So that's a great little start. All right. Let's go and tackle this problem involving rectangles. Write an equation that represents the perimeter of the model shown. Little vocabulary from algebra, from geometry. Distance of the object is called the perimeter. Distance around. A rectangle has four sides to it. P stands for perimeter. We're going to add up all four sides together because we're looking for the sum. L stands for length, W stands for width, and there are two more of those. Second question, rearrange the order of the sides so that you can represent the perimeter with a different equation. Is this equation equivalent to your first equation? We can clean this up. Recognize we have like terms. Look, there's an L right there and a W right there. L plus L is like saying 1L plus 1L is 2L. Likewise, for W, we get the same thing. 1W plus 1W is 2W. So you may have seen this formula before in your middle school days. The perimeter is twice the length of the side of a rectangle plus twice the width of the side of the rectangle. You can actually rearrange this a little further by factoring out a 2 from that binomial. When you factor or divide out by a 2, you're left with a L plus W. So this is two ways of representing the same equation. We took out a 2, that was called a factor. All right. And no matter which formula you use, you'll get the same answer. We're going to go ahead and skip to the next page. Turn to page 14, please. Here we go. All right. Example 1. What equation can Janet use to calculate the principal amount? The actual example they're referring to is in the section 1-4, example 1. It's on page 24. The formula they're referring to is the interest formula. There's a lot of variables here. I stands for interest. P stands for principal. R is the rate. Make sure you put it in a decimal form. And T, of course, means time. I'm going to take that equation, I equals PRT, and just rearrange the furniture. I know there are no numbers here, but just pretend to focus on the variable they want. They want us to calculate the principal amount. Principal is the letter P. I want to isolate that variable. Right now, there are a couple of variables next to the letter P. To move them to the other side of the equation, I'm going to apply the opposite operation of multiplication, which is division. Remember, when you divide, you have to apply it to both sides in order for the equation to be balanced. Times R times T, I'm going to go ahead and divide by R and T together at the same time. That's allowed. Bam. R and T go away on the right-hand side. P equals to I over or divided by RT. And ladies and gentlemen, that is your rearranged literal equation. Now remember, just recap, I was doing undoing operations where we're going backwards of PEMDAS. In terms of basically solving for the variable P. Okay, that wasn't too bad. Any questions? Let's move on to the next example, example 2. All right. Sarah is going to the store 2.5 miles away. She has only 15 minutes to get there before they close. At what average speed, let me underline that, must she ride to get to the store before they close? In example 2 in the book, they invoke this formula, which we brought up earlier. D equals RT. D stands for distance. R is rate. In the physics and math world, 2 other words mean the same thing for rate. That includes velocity or speed. T, of course, is time. All right. Let's take a look at this problem. What is the average speed? Speed is the letter R. So I'm going to take the formula D equals RT and rearrange the furniture. I want to isolate R by moving T to the other side. I'm going to go ahead and divide by T to the other side. When I do that, I'm left with R equals to D over T. The t's went away a moment ago. The distance is 2.5 miles. Let's substitute that into the problem itself. And I'm going to go ahead and convert that. So I can solve for it in a moment. Now keep in mind, time is 15 minutes. And when it comes to distance equals rate times time, it's usually miles per hour. So I need to convert that, I said a second ago, into hours. Using dimensional analysis, 15 minutes needs to be converted by multiplying it with a ratio of 1 hour over 60 minutes. When I do that, the units go away, the minutes units, and 15 over 60 can be reduced to 1/4 of an hour. Now, technically, 1/4 of an hour is 0.25 as a decimal. That's why I'm going to put 0.25 in the t position off to the left. I mean, you can use a calculator at this point. 2.5 divided by 0.25 becomes 10. Now, if you didn't do that, if you want to do it manually, you can actually move decimal points. Watch this. This is kind of cool. It's a trick I learned in middle school when I was a kid. You can slide the decimal points over. Whoa, whoa. In that case, 2 places. And there's that one. Put a little 0 in the placeholder. 250 over 25 is 10. And the units, of course, are 10 miles per hour. Not too bad. Let's go to the next page, example 3. Any questions? All right, here we go. Page 15. Rewrite a formula. Oh, write the formula for the area of a triangle, A equals 1/2 base times height, in terms of h. Let's pause for a second. I'm going to write this a little bigger. And we want to isolate the letter h, which stands for height, of course, from your geometry classes. Find the height of a triangle when A equals 18 inches squared and B equals 9. So before I do that, I just want to remind you where this formula comes from. A rectangle hides inside it an actual triangle. Those two formulas are related by a half. Half would produce the triangle. Without the half, would actually give you the area of the rectangle where the triangle comes from in the first place. Interestingly enough, base and height, in order to use this formula, must be at a 90-degree angle to each other. I will show you other scenarios that this can happen and it still works. Trying to draw the same situation. No matter where your base is and your height is, they have to be at a 90-degree angle with each other. And as you can see, this formula works for any triangle, whether it's acute, right, or even obtuse that I'm drawing here off to the side. That formula works fine with those three scenarios. All right, back to the original problem. We're trying to find the height The strategy is to rearrange the variables in this literal equation. We're going to rearrange the furniture, so to speak, and move everything away from the h. All right, we have a 1/2 times b times h. I'm going to move each little thing slowly over to the other side. I can multiply by the reciprocal 1/2 first. That's in the way. The reciprocal 1/2 is 2/1. Great. Doing that, I'll get 2a equals to, those 2's go away on the other side. That was the whole point in the first place, b times h. And then finally, b times h. I need to move the b over to the left-hand side. I'm going to divide by b to both sides. The b's go away. H equals to 2a over b. This is the literal equation. Now I'm going to answer the second question after I rearrange the furniture here. I want to find out what the height is if they tell me that the area is 18 and the base is 9. All I have to do is plug those numbers into the formula, and we'll get an answer here in a second. All right, 18 goes in for the letter A, representing area. That inches squared is just referring to the actual unit. That square does not affect the 18. It's just something standard practice that they use in the industry. Base is 9 inches, goes in the denominator. And here you just clean it up. Some teachers like to reduce first before they multiply. 9 goes in 18 twice. And yeah, 2 times 2 is 4. Don't forget about the dimension. I'm sorry, the units. The units are inches, okay? Wow. A lot of literal equations. I'm actually going to do one more literal equation and have you guys try the last page on your own. The do you know how on page 16. Let's go and end with example 4. Aha. Example 4 involves temperature. I'm going to go ahead and present something that we use in this country, Fahrenheit and Celsius. Fahrenheit is related to Celsius by multiplying with 9/5 times the Celsius value. Keep in mind, the rest of the world uses Celsius. We are kind of different in the United States, and we use something called Fahrenheit. So let's write those names down really quick. Fahrenheit. C stands for Celsius. And question, the high temperature on a given winter day is 5 degrees Fahrenheit. What is the temperature in Celsius? Now, the formula I gave you is in terms of Fahrenheit, not in terms of Celsius. So here, I know I could have given you the formula, but we want to practice rearranging the literal equation and isolating C. That is our goal before we solve the actual problem. Now we have 9/5 times C, and we have 32, which is plus. Just a quick reminder of rearranging the furniture. We want to undo operations and go backwards of PEMDAS, okay? We want to isolate the letter C. So in terms of that, adding, subtracting must come first. Let's move the 32 to the other side by subtracting 32 to both sides. When you do that, you have on the left-hand side F minus 32, and on the right side we have equals 9/5 C. All right, I think we have one more step here. The coefficient in front of C is 9/5. There's a cool trick. The trick is to multiply both sides by the reciprocal. Let me write that down. The reciprocal of 9/5 is 5/9. So let's do that. We're going to multiply by 5/9 to both sides. And the whole point of multiplying by 5/9 to both sides, it really does take care of two steps in one step. The 5 goes away and the 9 goes away, leaving with the letter C isolated. And boom, there's my literal equation set for C relative to F. But I'm not finished yet. I now have to take that newly rearranged equation and solving for C when the temperature on a given winter day is 5 degrees Fahrenheit. I'm going to go ahead and substitute. Whoa. Right there into that formula. Here we go. So I'm going to plug in the 5. Let's go ahead and simplify it. This is PEMDAS now. 5 minus 32 is negative 27. Negative 27 times 5/9. I prefer to reduce and then multiply first. Aha, 9 goes into negative 27 negative 3 times. And 5 times negative 3 is negative 15. Wow, that's a chilly, chilly temperature. Negative 15 degrees Celsius. Well, I'm going to leave it at that. I've done a nice variety of examples. I would like you to take on the challenge and try those problems on the next page and bring it in. All right, thank you very much. I hope you learned something today. I'll talk to you guys next time. Thank you.